Thank you. Thank you. I'm glad you can read my writing. It's pretty low. Bad. Hi everyone. My name is Sam. Welcome to my talk. Dry, wet, spot, what? Just, I don't know, clickbaity title. Why not? About me, I've been programming now for over 15 years. I started in 2008 with Xcode 3 and kept going, if you can believe that. I'm from New Zealand. You might be able to hear from my mumbly, fast-talking accent that I'm not from around here. I have born and raised in Christchurch, moved to Wellington and then to Auckland, and now I live in Sydney. So have joined the rest of you in this great country. I've worked in a series of businesses, small, large, medium, startups, agencies, and now more of an enterprise company. I've been lucky to work in iOS land, predominantly with Objective-C and a bit of Swift. I've spent my time with web, with React and Angular, and now I find myself in the back end, mainly in the Node.js ecosystem. These days, I'm an engineering manager at a company called Cochlear. We're a medical technology company that builds implants, so people that have lost their hearing or are born without their hearing can get their hearing back. I work on the back-end software that surgeons and audiologists and patients and their carers interact with via our mobile apps. Today I want to talk to you about code duplication, what it is, ways of handling it, ways of spotting it. Got some code demos for that. I'm going to introduce you to something called spot, and then I'm going to introduce you to something more interesting called connascence. I'm going to got some more code demos with connascence, and then I've got some mindsets for you to take away, hopefully, with you. Today's talk, I've written the code in Swift. It's not going to win any awards for the best Swift. John Sundell or Erica Sadoon's not going to come out here and shake my hand. But it is designed for you to go, oh yeah, I know what it's doing. It's conference code, not production code. I will refer to code unit in this talk. That refers to either like a method or a class or a module or a package, a microservice, an app, just a block of or a blob of code. You're welcome to live tweet during this on the micro-blogging platform of your choice. We've all disappeared to different ones and it's not fun anymore. But I'm Sam Jarman on most things, just search. Of course, thoughts today are my own, including awkward jokes under the pressure of giving a conference talk in front of a room full of people. Cochlear doesn't have thoughts on code duplication. Why would they? So let's get into it. Code duplication. Code duplication is when code is repeated in the same code unit. It's regarded as a code smell. Now we know what a code smell is. Code smell is suggesting something's died in the code base or something's rotten in the code base. It's sort of along the phrase of where there's smoke, there's fire. Code smell will indicate something's wrong here when there's code duplication. And so why is code duplication bad? We are told it's bad because when we have to change something in one place, in method A, we have to go change it in method B because they need to stay in sync. And hopefully you know about method B as well. You might not have written method B and you've written method A, or you're writing on method C, D, E, or F. And we might not be able to find all those places we need to change. And that's bad because then things get out of sync and we get bugs. And that adds maintenance burdens to our code base. If you need to go change 5 places every time you want to change the behavior of something, that's bad. We don't like code duplication, it's a code smell. So to combat this, largely popularized by the Ruby on Rails community, we came up with dry. Don't repeat yourself. It's a popular phrase and mindset for avoiding code duplication. It's very easy to understand. If you write code and you've seen it before, don't do that. Call the method or the package or the microservice again. It's easy to do because you can just use your tools to refactor, not Xcode users, sorry, but other good IDEs can do that. Generally speaking, you can collapse things down into methods or some sort of reusable code unit, and that's going to do. It's also easy to do after you've written the code. Sometimes you can only spot the fact you've repeated yourself once you've repeated yourself. So dry is something that people do a lot. It's very easy to understand, and we teach at university and sort of stuff now, and it's okay. On the other end of the spectrum, we have Yagni. Has anyone heard of Yagni? Yeah, cool. It stands for you ain't gonna need it. It's a pretty jargony sort of phrase, or slang sort of phrase. It discourages over-engineering. There's this famous joke of you ask a programmer to pass you the salt and pepper, 20 minutes later, still no salt and pepper, they're busy building an arbitrary condiment dispenser. Because programmers love to just geek out, over-engineer, and build something way more unnecessary, way more redundant for the use case that was specified. And this is kind of where Agile comes in, trying to convince developers just to build what they need, ship it to customers, see what they think, and then iterate. Yegni is one of these phrases which is like, okay, if you're thinking about reducing duplication in your code, don't worry about it now. It might be more obvious later, or if you're tempted to build some sort of reusable unit of code, just don't. You're over-engineering. Let's just get this out the door, close the ticket, ship it to customers, and move on. So this forms a spectrum. On one side, we have dry. On the other side, we have yegni. There's something in the middle called wet. Now, the person who came up with the wet must have thought they were really clever, because wet and dry are like opposites. And wet is write everything twice. And this is the mindset I was using when I was working with James a lot in a React code base. So I'd write everything twice, and if I was doing it a third time, hey, this is a really good signal that this is going to repeat itself over and over again. So it's time to refactor and make a sensible code unit. That could be like a Swift UI component, a little view, a module, a view model, any sort of code unit. It's a good time to refactor. And it's kind of the sweet spot between dry and yegni to say, okay, I won't prematurely optimize my code base or prematurely over-engineer, and I won't let it become a mess, but I'll try to find a middle ground. So in summary, there's dry, wet, and yegni, and these are the popular ways of thinking about code duplication. I think they're all wrong, and I want to tell you today that it's just more subtle than that. Like most things in the world, it's a bit more complicated than perhaps it first seems on the surface. I want to tell you today that duplicating code, sometimes okay, totally okay, and I want to tell you about why. So let's go over to Xcode. I haven't used Xcode in a while, but I've been writing some code. So here we have a simple person class. Oh, I've used classes and not a struct. It's okay. And it takes 3 arguments in the constructor: first name, last name, nickname. And there's a function called build name. Can you all see that text? Is that all right? Do I need to zoom in? No? Cool, cool. So when you call build name, it builds a string for you using string interpolation. And it comes out here like on line 20. When you call build name, comes out Dwayne "The Rock" Johnson. I'm sure we all know about the actor The Rock. He's in a series of good films, and in between each good film there's a bad film. So simple person class with a build name, sweet. My code base is off to a good start. Sprint 1 done. Now let's say we want to extend that person class. Let's add another method here. So I've got a method called getFunEmailSignature. This is something that will get inserted every time this person sends an email from our system. Now, I say fun, you could argue it's lame, but it's catchy on the flip side, buddy. Dwayne "The Rock" Johnson. But we're starting to see some duplication here. We've got these characters here are also down here, which is starting to get, dry. It's not dry enough. I'm worried. So we kind of, worry about that, but maybe it's okay, maybe it's not. So moving on, we got over that lack of dryness. It's, we'll probably spot that, it's fine. But now another person enters the code base. We have a doctor. And a doctor also has a first name, a last name, and for some reason nicknames. So we get Bruce Banner in the code base, and he's Bruce the Hulk Banner from obviously the Marvel series. And that's great. Look, we've got another person, build name. I've re-implemented that build name function. Easy stuff. Feeling a little bit uncomfortable about that duplication though. So I thought I might dry out this class a little bit. So in the getFunEmailSignature, I've now, can't see the laser on there, I've now just called build name from inside the other function. So now if I want to change the way the name's formats, I've got one place to change it, and this just works, because that comes up to there and then executes this. So that's great. And then all that's new in that getFunEmailSignature is the little sign-off line, which is pretty cool. But down in the doctor class, we've still got 2 implementations, or a second implementation of the build name function though. So if I wanted to change it for both, I've got to go change both classes. So I'm getting nervous at this point, but don't worry, they taught me about inheritance at university. So now I've got a class called basePerson. This implements a build name function, and then I implement person that inherits from basePerson, and I can override it, just add the method called getFunEmailSignature. I can call super.buildName, that calls the build name from the parent class, and that's great. And down here in Doctor, I can implement the Doctor class without any overrides. That's really helpful. And now it's dry. So if I want to add you know, more quotes around the nickname, one place to change it, it all just works. Feels good, man. Tried out in my classes. I'm a great programmer. Then your product owner, or the person who controls what you kind of put in your product, comes and says, hey, can we get MD, medical doctor, added to the end of doctors' names? And you're like, yep, don't worry, I learned about override functions and my language supports them. So I can just call super.build name and I can add on space and MD. See what I mean about not production code? So now I get Bruce the Hulk Banner, MD. He's also got like several PhDs, but that's okay. So now, in Sprint, what are we up to? 4, 5, 6. We've got our base person, it's working great. Got our person working great. Got our doctor. But now we have to add a teacher to the code base as well. And so the teacher has a first name, a last name, a nickname. They also have a title, like Miss, Ms, Mr, Sir, Ma'am. And so their title is just, you know, their name is just their title, last name. You don't call their teachers by their first names. That would be weird. They are Mr. Jarman. So when you build a name, it comes out as, in this scenario, Miss Honey. So we've actually kind of done a weird thing. We built a base class and then we just overrid it everywhere. So that was kind of weird because, like, what was the point of the base class now? In our attempt to dry everything out, we've made the code more complicated and we haven't really achieved anything in terms of code reuse. So was that attempt at dry even worth it? So let's go back to the slides. So there is types of duplication. This is one thing I want to make clear today. There's types of duplication. There is what I'm calling accidental duplication, and then there's deliberate duplication. Now, in the deliberate case, these two things have to be the same in order to maintain system correctness. So in that example we just did, the build name function within a class, say just person, the build name output and the name part of the fun email signature absolutely had to be the same. That is the way we display that type of person's name everywhere in the system, or in emails or whatever. They have to be the same. But then there was some accidental duplication where things happened to be the same. They didn't have to be the same, they happened to be the same. And that was when doctor temporarily had the same name formatting as person, with the nickname included. And remember, that didn't last for long. And why that is code exists through time. We have a special type of engineering and software engineering, and we work in the fourth dimension. We don't just ship an app, job done. We don't get to just build bridges and the bridge works great, admire it for many, many years to come. We write code in the fourth dimension through time. And so the question you ask yourself is, these two things are the same, but will they always be the same? Do they have to always be the same? This is kind of like Yagni, but it's a cleaner way of thinking about it. Not you ain't going to need it, but like, will you need it? So what is the solution? The solution is Spot. I use Google Slides, not Keynote anymore, sorry. Spot stands for single point of truth. In our person class, we had 2 points of truth for what the nickname, or what the build name function should do, or how the name should be displayed. That was bad. So we wanted to, so when we did the refactor to just call the build name function from within the get fun email signature function, that was us taking 2 points of truth and making it 1. Good. But then the doctor versus person, for example, they were 2 individual sources of truth. They were temporarily the same, but they had their own truth. So forget dry wet and think about Spot. Now there's a term called coupling here, right? And a coupling means if I have to change 2 places or n places in a code base to keep the system overall correct, without bugs, looks normal, works fine, then the things are all coupled together. So coupling is something we like to avoid, but we don't really have good tools to talk about coupling and what it is until today. Connascence. Connascence is a measurement of coupling. Dictionary definition would be a common birth of 2 or more things at the same time, things that are born or produced together, or the act of growing together. And code bases and code units, they grow together. Page-Jones, he invented this in 1992, a fantastic year for people to be born. Connascence is a software quality metric to allow reasoning about the complexity caused by coupling. So we know coupling is bad, but like, how is it bad? Why is it bad? And we say things are coupled, or we can say they're connascent if a change would require multiple changes in the code base to keep that correctness overall. There are many different types of connascence. There is connascence of name, type, meaning, position, algorithm, execution, timing, value, and identity. There are strengths and degrees of connascence, where from the top of the list to the bottom of the list, we get from weaker to stronger. And as you get more of them, you get a higher degree. So the more connascence that is present, the worse your code base is, or the more smells it has, the more problems it objectively has. There's also locality. How far away are these two things that have to be kept in sync? They could be in the same class, or they could be in the iOS app and the Android app, or the iOS app and the back end, or the iOS app in your company and the iOS app in the company you just merged with. Locality comes into account when we talk about connascence. Connascence can also be divided into two groups. There's static, something your compiler might be able to tell you about, or dynamic, something your code can tell you about when it's running, or worst case scenario, something your user tells you about. So static, dynamic. So let's talk about static connascence by going back to Xcode with one hand. So we have here a struct called customer. Not a very complete model. Has a property on it, age as an integer. So if we want to create a customer, we just pass through an age, and that's great. But what if we changed age to a capital A? Now I've turned off errors in this because it makes a mess if they do come up, but this would error out on line 5. The reason for that is your compiler says, hey, this argument name in the constructor of customer doesn't match with the property in the struct. Perfect, that's exactly what I want. Connascence of name is the weakest or the best connascence to have, because something as simple as checking variable names is something your compiler can do for you, and it's one of the reasons it does it. So it's very weak. So names are very good forms of connascences. But there's also locality when it comes to name, right? If you have your customer and you have, you're passing your age, what happens if that age has to be represented somewhere else? Perhaps you're persisting that to a SQLite database, core data database, realm, anything like that, or a server. This is where locality comes into play. And this is where you get help from automation tools that keep those two sources of truth in sync. Things like Codable, things like ORMs, things like core data. They will keep, you know, the where your truth is in one place in sync with the other place. That's why they exist, because it's a pain when you try to persist a object and the names don't match. All right, moving on to connascence of type, right? Connascence of type, also something your compiler will help you with in a language like Swift, because we have type checking. If I create a function called greet that takes a name and I call it with a string, that works. If I call it with a number, that doesn't work, that won't compile. This is why people like TypeScript over JavaScript, because types come into TypeScript and it can check things for you like this. So greetings, or any functions like that that take types, will do type checking. So having things that are using type is a good form of connascence. And it means that if you change the type that this function takes, it will propagate out through compiler warnings, right? You'll get told every place in your code base that you called greet, and like, hey, we were previously taking a string, now we're taking an array of string to greet more than one person, and that type's gone from string to array of string. It's a good connascence because it can be assisted by the IDE. There's also connascence of meaning. So here, I've written a simple linear search. You get given a list of numbers and a number to find. It will loop through one at a time. If it finds the number, it returns the number. If it doesn't find the number, it returns -1. So there's a meaning here that all people using this function have to agree that -1 means the number was not found. And there's a surprising number of APIs out there in different programming languages where -1 means a bad thing. But what if you had -1 in your array that you were trying to find? If it returns a -1, has it not been found, or was it in the array and found? So we're like, okay, we'll just make it -99. And we just kind of get into a little loop there, negative 999, negative int max, and that kind of gets a little weird. So something you might do in Swift is go back up the connascences from connascence of meaning up to connascence of type. We have optionals in Swift, which indicates, and all Swift developers agree, this thing could be here or it could not be here. These sort of optional types, maybe types, box types, are present in many programming languages for this reason. Out of the box, it gives you something to say, this thing is optional, right? And this could be return types, this could be fields and table view cells, it could be anything. But by returning nil in here, we go, okay, yep, nil is and nil can't be in the array because the array takes an array of int, not int optional. So we can say, yep, if we return nil, that means it's definitely not there. And then you can use like if-let syntax and all that sort of stuff that helps you write good code. But even then, that's still connascence of type. We can move up to connascence of name, right? We have to agree as Swift developers that nil, in the case of an optional int return, means it's not found. But we can actually just give it a name too, not found number. And then it's very clear that this thing can return not found number, and you can check it to be like, if find number 4, it's not found number. And that's going all the way back up to connascence of name. So if you want to change how you return a lack of value from nil back to 0 or negative int max or positive int max or something else, as long as code is still just using a check for not found number, it'll compile, it'll work, it's fine. Back up to connascence of name, brilliant. However, for Swift developers, you'd probably prefer to use int as an optional because you get that nice if-let syntax. So let's talk about connascence of position, the next one, where the order of things matter as you're calling a function in a class or a free-flowing function. So we've got a function here, build name, very similar to the one from earlier, returns a string, and you can say, right, these two functions, and I've had to sort of hack at Swift a little bit to take off function names, so argument names, these two will compile, but there's a bug here, right? Because you have to call the function the right way to indicate which of these three strings is the first name, the nickname, and the middle name. Sorry, the last name. So calling it by Dwayne Johnson the Rock is actually correct because I've asked for the nickname third. If you call it, and you might want to call it in the way that you think it's going to print out, Dwayne the Rock Johnson, that's actually wrong. Now types can help with this if you consider a function like build name number 2, which takes a string at the end for the age. The types will start to error on line 20 and 22, or line 20, just line 20, because types can say, okay, I expect 3 strings, then an integer, and if you've given me an integer and then 3 strings, types can start to help in this functionality. But then, you might know your clean code wisdom where it's like, okay, if you've got many arguments to a function, you can use structs. Well, the answer in Swift is to use named parameters, which is actually the default. And so that allows you to actually see at the call site if you've done the thing right. It doesn't necessarily enforce it that much, but it can help really well. So using structs or objects or any sort of named parameters, named arguments, can help a lot when it comes to making a call site that is not vulnerable to the connascence of position problem. There's also the connascence of position where people try to use more primitive types of data structures to represent stuff. So you think of like a list literal, and the first item is always the first name, the second item is always the nickname, the third item is always the last name. You can just get the person's last name out by going to position 2 with a 0-based index. Just use an object. This is why we have objects. They're great. Use them. Objects or structs, I don't care. Finally, there's connascence of algorithm, which is kind of the one I'm talking about all day today, which is two or more places have to agree on the algorithm. So in this scenario, we've done the connascence of algorithm right because build name is in a single place and it gets called every time it's needed, whether or not that's private or internal to the class or external to the class, which makes things really nice. So that's the static connascences. There's also dynamic connascences. I'm just going to check how I'm going for time. Didn't even start the timer. Great. First one is execution. So if order matters, this is connascence of execution. If you need to call code unit A before you call code unit B, always, there's coupling there. Because code unit A has some sort of side effects or put the system in some sort of state that code unit B relies on. And that could be, writing a file to disk or putting something in the cloud or whatever that module B relies on. Those two things are inherently coupled now, because if you don't call them in this order, then you've got a lack of system correctness, you've got a bug. So in these sorts of situations, you might go, well, if this has to be coordinated like this, maybe I write a function that just says do the thing, and that function takes on the work of going module A, then module B. Or you combine them into a single module. And then from there you have one single place that has the connascence of algorithm back up to a static connascence, a weaker connascence, that defines the order of the ways the modules are called. So yeah, that's connascence of execution. Similar but different is connascence of timing. And that's when timing comes into play, where you have to wait for a module to finish before the other one can start, or the other one's got to finish before the other one finishes, or anything like that. We call these race conditions. We know race conditions are bad. This is why, because race conditions indicate there's a problem in the system because the timing or the execution has gone wrong, and that's if the timing or execution doesn't go the way you expect it to as a programmer, the system is incorrect. And we don't like having race conditions because it's hard to find. Your compiler can't find it. You only find it at runtime, and if you're lucky, you find it at runtime, and your user doesn't find it at runtime. Next up is connascence of value. Now you might have come across this. When two sources of data, like in a database, have to agree on the value of something. And this is super common when you have two databases that are syncing back and forth, or any integrated systems. Maybe you've been in a company that's gone through an acquisition, and they've got a user A, and then you've got the same user, and they've got some data that belongs to that user, and you've got some data that belongs to that user, and you need to check who's got the data, and you have to kind of sync back and forth. You have to maintain a list of all the identities, and that's really annoying. And this happens all the time. It also happens all the time. There's also connascence of identity, which is a sort of a subtype of connascence of value. Identity is when you've got multiple resources that have to be known by the same identifier. So this is probably a better example of the two people in the same database. Connascence of value is more like you've got two values. So you've got, let's say you're doing a loyalty system. This system over here has a number of points. The system over here has a number of points. Let's say, I don't know, you're an airline, you sell holidays and flights. You buy a flight on points. If you go to the holiday section, you should see your points have decreased because you've used them over there. If those systems aren't talking, it's weird and that's buggy. Connascence of identity is more about identity, which comes in with a whole breed of problems, right? And this is particularly annoying when you get married and your last name changes, or you transition gender and someone calls, the software system would call you by your old name or your dead name. That can be particularly offensive to people who have transitioned gender or changed names. So you don't want to do this. And there's good software patterns out there for keeping these things in sync. But if you have this problem, try to get rid of the problem rather than syncing. It happens everywhere, even happens at dev world. We've got two identifiers for the same real world human. So if someone asks for Tim, they might be asking for Tom. If they're asking for Tom, they might be asking for Tim. It's a real problem, and you have to know this to work through that connascence of identity problem. Locality, I was told you was coming, had to come. We're off, we started dev world. Now there's also locality. Locality refers to where the code units are. And this is kind of a unique, I don't want to say fun problem, but a unique problem for iOS developers, because often you'll have to implement the exact same thing that was on Android, or they have to implement the exact same thing as you. And that could be anything from like the validation of the email address and sign up. It could be how the loyalty system works inside the app, how the search functionality works inside the app. Even here at Seek, right? You can search for jobs on the Seek app. There'll be an iOS app and an Android app. Both of those apps should return the same results if you search iOS developer Melbourne. And that's why they might put that search on the server, one place, one algorithm. And the locality is better, right? Because then both apps just call the server returns the results, and that's why we like patterns like dumb clients, or we like patterns like reusing modules between iOS and Android, even though it's hard and annoying. Anything that has to be the same between iOS and Android, that has to be implemented on iOS and Android, preaching to the choir here, is annoying. So locality makes a difference. The further away these things are, the harder it is to maintain. Because if you're an iOS guru at, let's say, Seek, you might not talk day to day to the Android gurus. So if you don't do that, chances are you'll introduce a bug or an inconsistency between the two experiences, and that's bad for business. It's even worse. If Seek goes out and buys other job site X, and then they have an app as well, and then you can join Seek through the other app, and you can join the other thing through the Seek app, and one person allows a@a.com and the other one doesn't allow a@a.com for the email address, that's bad. So trying to keep your sources of truth near to each other is a good idea, because the chance of keeping them actually up to date and in sync and keeping a single point of truth across them all gets much higher. So that's connascence. We always aim for weaker connascence. We expect within a code unit more connascence, more sources of truth in the same place. Between code units, we expect less connascence, so less sources of truth spread out between different things. Lowering connascence between code units makes things more cohesive. They work better together, and they can stop working together if they wish. So I want you to just ask yourself these questions as you go away today. What else do I need to change if this changes? Piece of code, code unit, package, application, microservice, endpoint, whatever. Does this happen to be the same, or does it have to be the same? Are we talking about a source of truth, or just things that are temporarily overlapping? Am I duplicating code, or am I duplicating a truth? And that truth can be any of the connascences, the names, all the way to algorithms, all the way to identity. What is the connascence here? Using the schedule, using the guide I've given you today, can I lower it? Can I use constants to indicate special values? Can I use types in my naming? Can I use Swift best practices in order to lower my connascence? Can I make the Swift compiler help me help myself? So, if you want to learn more about connascence, this talk is basically a rip-off of 2015 talk by Josh Robb, a friend of mine, called Connascence and Coupling. His talk is in C#, so if you understand C# better, have a look at that one. There's also a Wikipedia page on connascence, and there's also a blog post on codesci.com about connascence. Once again, connascence is a 30-year-old concept. I think all of you today would have felt some of these things. You would have known some of these things, not necessarily by the names I gave them, but hopefully I've given you a framework today that makes sense of all these things that you think you've brought up, all this wisdom that you've acquired over time. Connascence is the unifying grand theory of coupling. Thank you very much.